So in this video, we're looking at rational functions, and in particular graphs of the form, a function of functions of the form f of x equals ax plus b over cx plus d. So a linear function over a linear function. Well, let's have a look at some examples. Best way to look at these. All right, so graph the following functions. Our first function is f of x equals 3 over x plus 5. Okay, so we need to graph this. So we need to figure out a few things, or we need to find a few things. So what things do we need to find? Or at least find in terms of giving us some indicators to help us graph or sketch the function. So the first is the x-intercept. So how do we determine what the x-intercept is? We need to solve f of x equals 0. Unfortunately, it's not possible for f of x to equal 0 ever, because what values of x give 3 over x plus 5 equal to 0? None. So there's no x-intercept. No x-intercept. And that's fine. Now let's look at the y-intercept. When does the y-intercept occur? The y-intercept occurs when x equals 0. So let's plug x equal to 0 into our function, and we get 3 over 5. So therefore, y equals 3 over 5 is the y-intercept. Good. All right, so the next thing we want to look for is the vertical asymptote. So we're just going to use VA for vertical asymptote. The vertical asymptote occurs when our function's undefined. So when is our function undefined? When x plus 5 equals 0, or when x equals -5. So this is our vertical asymptote, x equals -5. So what is our horizontal asymptote? Our horizontal asymptote can be determined by letting x become a very large number, so go off to infinity in the positive or negative direction. So we are going to look at the limit of our function as x goes to positive or negative infinity. Sometimes we have to consider the limit as x goes to positive infinity independently from the limit as x goes to negative infinity, but in this case, we don't need to. The function is going to end up going off to the same value. So notice that x is in the denominator. As x gets really large, we're dividing 3 by a very large number. So that means our limit is approaching 0. So therefore, y equals 0 is our horizontal asymptote. Good. Okay, so what do we have? So far we have our y-intercept is y equals 3 over 5. We have no x-intercept. We have vertical asymptote, horizontal asymptote. Now let's consider, let's scroll over to the right. Let's consider when the function is positive or negative, so the intervals. So we need to take our real number line, and divide it up into intervals. So the best place to divide it up is at the value where x, the value where the function cannot equal some x value. So for example, the vertical asymptote, -5. So when x is less than -5, and when x is greater than -5, those are our two intervals. If we had like an x-intercept, we'd include that into the mix too, but in this case we don't. So now let's look at our function 3 over x plus 5. We only have the one factor, x plus 5. Let's see what the sign is of our function. So when x is less than -5, 3 over x plus 5 is negative. When x is greater than -5, 3 over x plus 5 is positive. Good. Took me a little while to see that. Okay, so we've got that information, so that's good. So now let's graph our function. So let's put it all together. Let's draw some axes. Okay, it's the first thing. Okay, so now let's put in our vertical asymptote, which is at -5. So let's put a dotted line in there. It's not very much of a line, is it? It's not very straight. Okay. Well, how about this? Let's actually use a line. Okay, that's pretty close. Okay, that's our vertical asymptote. Let's just label it y equals -5. Sorry, x equals -5. And our horizontal asymptote is actually y equals 0. Okay, so now we can label our x and y axes. And now, where was our y-intercept? 3/5. We had no x-intercept. Now let's draw our function in. So we know it's positive when x is greater than -5, and we know it's negative when x is less than -5. Whoops. There. It looks something like that. So it gets very close to our asymptotes, but never touches them. Both are vertical and horizontal. So this green curve, our green curve is our function 3/x plus 5. Okay, so let's look at the next one. What do we have here? We have, I think we have one more, f at x equals x minus 1 over 2x plus 3. So again, we need to go through that list of items that we require, like x-intercept. So how do we find the x-intercept? We need to solve f at x equals 0 for x. So let's do this. So 0 equals x minus 1 over 2x plus 3. When does this occur? This occurs when the numerator is 0, so when x minus 1 equals 0 or x equals 1. So that's our x-intercept. So we have one this time. Our y-intercept. How do we determine our y-intercept? We plug 0 in for x and we solve. So when x equals 0, we get -1 over 3. So therefore, y equals -1 over 3 is our y-intercept. Next, our vertical asymptote. How do we find our vertical asymptote? That's when our function is undefined. So let's solve. So sorry, that occurs when 2x plus 3 equals 0. And then we can solve for x, and we get x equals -3 over 2. That's our vertical asymptote. How do we find our horizontal asymptote? Where can we do that? Let's do that here. Horizontal asymptote. Remember, we take the limit as x approaches positive or negative infinity. So it gets very large, and we look at our function. X minus 1 over 2x plus 3. Okay, so there's a little technique for this. We're going to divide everything by x. So the numerator, we divide everything by x, we get 1 minus 1 over x over 2 plus 3 over x. And now as x gets really large, either negatively or positively, this term here goes to 0. 1 divided by a really big number is really small. And this term, 3 divided by a really big number, also goes to 0. So therefore, this limit is actually a half. So therefore, y equals 1/2 is our horizontal asymptote. So something else that's nice to know is our domain and range. So we didn't look at that in the previous exercise, but let's look at it here. So the domain in this case is all real numbers. The domain for our function is all real numbers except when x equals -3 over 2, because that I believe is our vertical asymptote, and we can't, so we're never going to attain that value for x. Our range, again, all of y values that are real such that, oops, y does not equal 1/2. So that doesn't look very good there. Sorry, in the domain x does not equal -1/3. So that's when -1/3 is our vertical asymptote. And in the range, all real numbers except where the horizontal asymptote, which is y equals 1/2. Now we'll look for our intervals where our function is positive or negative. Let's look at our real number line and divide it up. So we're going to take our vertical asymptote, which is -1/3, as 1 point. We're going to take 1, our x-intercept, as another point, and divide up our line, or real number line, or a domain, into the regions x less than 3/2, x greater than -3/2 and less than 1, and x greater than 1. And our factors are 2x plus 3 and x minus 1. And then we're taking the quotient of this. So we're doing x. Our function is x minus 1 over 2x plus 3. Okay, so now let's figure out when these factors are negative and positive on these intervals. So 2x plus 3 is negative when x is less than -3/2, positive when x is between -3/2 and 1, and positive when x is greater than 1. Now x minus 1 is negative when x is less than -3/2, and negative when x is less than between -3/2 and 1, and positive when x is greater than 1. We take the quotient, we get positive, negative, positive. Okay, so we've got this information. Now let's graph our function. Where should we do that? Let's do that down here, right below. Let's draw our axes in. Okay. Let's put in our vertical asymptote. Let's do that in red. Oops. Okay, let's make a nice straight line. Okay. And let's put in our horizontal asymptote. Let's do that in red too. Our asymptotes are in red. Let's label them. The horizontal asymptote is when y equals 1/2. Vertical asymptote when x equals -3/2. Let's put in our intercepts. So x-intercept is actually 1. Y-intercept is -1/3. Okay, I think we have all our information. Let's label our axes. And let's draw in our graph. Okay, so we know our function needs to pass through these 2 points. Whoops, not so great. It's a sketch, right? Good. And then, right, so we know from our table our function is negative between -3 and 1. And then it's positive for x greater than 1. And we also know that our function is positive when x is less than -3. So these 2 green curves make up our function. F at x equals x minus 1 over 2x plus 3. Good. Okay, so that brings us to the end. If you have any questions, send us a note at info@raisemymarks.com or give us a call day or evening. And thank you for watching.